According to the National Electrical Code, or NEC, PVC conduit buried underground must be at least 24 inches deep. In this case, the proposal is to install the conduit 48 inches below the pond floor, which is deeper than the minimum requirement. Advantages of PVC conduit are firstly, corrosion resistance. PVC is non-metallic and highly resistant to corrosion, making it suitable for use in wet environments such as beneath a pond. Secondly, lightweight. PVC is lighter than metal conduits, making it easier to handle and install. Thirdly, cost effectiveness. PVC conduit is generally less expensive than metal conduit. Concerns with PVC conduit are firstly, pressure rating. PVC conduit has a lower pressure rating than metal conduit, so it is important to ensure that the conduit will not be subjected to excessive pressure from the weight of the pond water or any other external forces. Secondly, impact resistance. PVC conduit is more susceptible to damage from impact than metal conduit, so it should be protected from potential impacts by providing adequate burial depth and erosion control measures. Based on the information provided, it is technically feasible to use PVC conduit for this application, provided that the conduit meets the following criteria. Firstly, depth. The conduit must be buried at least 48 inches below the pond floor. Secondly, pressure rating. The conduit must have a pressure rating sufficient to withstand the weight of the pond water and any other external forces. Thirdly, impact protection. Measures must be taken to protect the conduit from potential impacts, such as providing additional burial depth or running the conduit through a protective sleeve. If there are concerns about the pressure rating or impact resistance of PVC conduit, consider using an alternative material such as firstly, steel conduit. Steel conduit is stronger and has a higher pressure rating than PVC conduit, but it is also more susceptible to corrosion. Secondly, high-density polyethylene or HDPE conduit. HDPE conduit is similar to PVC but has a higher pressure rating and is more resistant to impact. Ultimately, the best course of action is to consult with a qualified electrical engineer to assess the specific conditions of the project and make a recommendation on the most suitable conduit material and installation method. A 55 amps 208 volts 3-phase pump can be fed from the service using one 1/2-inch conduit with 3 number 1 wires and 1 number 8 ground wire. The National Electrical Code, or NEC, specifies minimum burial depths for underground electrical conduits. For PVC conduit, a common choice for underground installations, the minimum depth is typically 18 inches for residential branch circuits rated at 120 volts or less. However, for installations under roadways, driveways, or areas subject to heavy vehicular traffic, the required depth increases to 24 inches or more. In this scenario, since the conduit will be buried under a 12-foot deep holding pond, it is already well below any surface traffic. The proposed depth of 48 inches exceeds the typical minimum requirements for underground burial. PVC conduit offers several advantages. Firstly, it is resistant to corrosion, which is a significant benefit in damp or wet environments like a pond. Secondly, it is lightweight and easy to install. Thirdly, it is generally less expensive than metal conduit options. However, PVC conduit also has some limitations. Firstly, it has a lower mechanical strength compared to steel conduit, making it more susceptible to damage from impacts or crushing forces. Secondly, its temperature rating may be a concern in extremely hot or cold climates. To determine the appropriate size of the conductors and conduit, several factors must be considered. Firstly, the load requirements of the 55 amps, 208 volts, 3-phase pump. Secondly, the ampacity of the conductors, which is the maximum current carrying capacity of the wire. Thirdly, the allowable voltage drop over the 500-foot or 1,000-foot run. Fourthly, the conduit fill, which is the percentage of the conduit's cross-sectional area that is occupied by the conductors. According to the NEC Table 310.15, the 16 number 1 AWG copper conductors with a 75 degrees Celsius insulation rating have an ampacity of 130 amps. This is well above the 55 amps required for the pump, providing ample capacity and minimizing voltage drop. For a 55 amps, 208 volts, 3-phase load, the minimum required conductor size can be calculated using the following formula. Firstly, calculate the load current. Load current equals power divided by voltage divided by the square root of 3. Assuming a power factor of 0.85, the load current is approximately 20,800 watts divided by 208 volts divided by 1.732, which equals 57.7 amps. Secondly, apply a safety factor. To account for potential overloads or future expansion, it is common practice to apply a safety factor of 1.25 to the calculated load current. Adjusted load current equals 57.7 amps times 1.25, which equals 72.1 amps. Thirdly, select the conductor size. Based on the adjusted load current of 72.1 amps, a number 4 AWG copper conductor with a 75 degrees Celsius insulation rating would be sufficient, as it has an ampacity of 85 amps. However, the initial specification of number 1 AWG conductors provides a significant margin of safety and minimizes voltage drop, especially over the long run. The NEC specifies requirements for equipment grounding conductors or EGC to ensure the safe grounding of electrical equipment. The size of the EGC is based on the size of the ungrounded conductors. For number 1 AWG conductors, the minimum required size of the copper EGC is number 8 AWG. The initial specification of a number 8 AWG ground wire meets this requirement. The NEC specifies maximum conduit fill percentages to prevent overheating and ensure ease of installation. For 3 or more conductors, the maximum allowable fill is 40%. To determine the appropriate conduit size, calculate the cross-sectional area of the conductors. Firstly, the cross-sectional area of a number 1 AWG conductor is approximately 0.166 square inches. Secondly, the cross-sectional area of a number 8 AWG conductor is approximately 0.21 square inches. Thirdly, the total cross-sectional area of the conductors is 3 times 0.166 plus 0.21, which equals 0.519 square inches. Determine the required conduit size. Based on the total conductor area of 0.519 square inches and a maximum fill of 40%, a 1/4-inch Schedule 40 PVC conduit would be sufficient. However, the initial specification of a 1/2-inch conduit provides additional space for ease of installation and future expansion. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 5% for branch circuits and 3% for feeders. To calculate the voltage drop, the following formula can be used. Firstly, voltage drop equals 2 times current times length times resistance per unit length, where current is the load current in amps, length is the length of the conductor in feet, and resistance per unit length is the resistance of the conductor per foot. Assuming a load current of 57.7 amps, a conductor length of 500 feet or 1000 feet, and a resistance of 0.126 ohms per 1000 feet for number 1 AWG copper conductors, the voltage drop can be calculated. For a 500-foot run, voltage drop equals 2 times 57.7 times 500 times 0.126, which equals 7.28 volts. Percentage voltage drop equals 7.28 volts divided by 208 volts, which equals 3.5%. For a 1000-foot run, voltage drop equals 2 times 57.7 times 1000 times 0.126, which equals 14.56 volts. Percentage voltage drop equals 14.56 volts divided by 208 volts, which equals 7.0%. The voltage drop for the 500-foot run is within the recommended limit of 5%. However, the voltage drop for the 1000-foot run exceeds this limit. To reduce voltage drop, consider using larger conductors or installing a step-down transformer closer to the load. Considering the specific requirements of this project, the initial specifications of 1/2-inch conduit, 3 number 1 AWG conductors, and 1 number 8 AWG ground wire appear to be adequate for the 55 amps 208 volts 3-phase pump, even for the longer 1000-foot run. The PVC conduit is suitable for direct burial at a depth of 48 inches below the pond floor, as it meets or exceeds the minimum depth requirements specified by the NEC. However, it is crucial to ensure that the conduit is properly installed and protected from potential damage during and after installation. To ensure the long-term reliability and safety of the electrical installation, it is highly recommended to consult with a qualified electrical engineer or licensed electrician who can assess the specific site conditions, perform detailed calculations, and provide expert guidance in the selection of appropriate materials and installation method. They can also ensure that the installation complies with all applicable codes and regulations.